So welcome all. Good morning. And today's topic, architecting cloud native applications for Azure. We will be covering a lot of things. There is a POC, converting a simple app to containers, and taking that to multi-tenant and see how exactly this all fits in with the databases, different databases, converting from MongoDB to CosmosDB. A lot of things going to be discussed today. And today we have Shivam as well will be the speaker. And before that, it's very important to note that, you know, make sure you're aware of others and make sure that you're friendly while post something in the chat. Yes, of course, we will try and answer all the questions. Sometimes some of the questions gets missed, so be friendly there as well. And due to time and various other things, and make sure you adhere to this code of conduct at the reactor. And I welcome Shivam. Shivam is an amazing speaker. He's an architect. He's a co-founder of TechScalables. You can see from there that he's amazing at Azure, machine learning, and blockchain. And obviously, the way he delivers these workshops, I just love that. And I attend all his workshops, by the way, at the reactor for sure. And I make sure that I learn so many things, including the diagrams he built. Thank you for that, Shivam. And I'm handing it over to you, Shivam. Just can you share your screen and get started with this?
Okay, so I'll share my screen. Thank you, Vivek,
Yeah.
for the lovely introduction. And hello, everyone. How are you? Hopefully, everyone is doing is well. You're at home. You're safe. And today we will be talking about architecting cloud native applications on Azure. So let me just quickly copy the agenda as such over here. Yeah. Okay. So if you have joined us for the previous sessions where we discussed about GitHub Actions. Then we talked about the CICD pipeline, and logically we will be. If you have not joined us for those sessions, it's totally fine. We will be starting from you can say from a label where even if you are new to the cloud native applications, then also you can understand it. Even if you have intermediate understanding of the cloud native application, then also this session will be for you. Now let me just quickly disable my camera so we can focus on the screen. Okay. Now we will be talking about, so as part of the agenda, first we will start with what is cloud native. We will understand the various elements of cloud native, the design patterns which are there. We will understand the pillars of cloud native. How do you deploy them in Azure? And once we have understood that, we will also go through some of the communication mechanisms which we come across when we deploy microservices, and we will use one of the communication mechanism in during the deployment. And we have one microservice to deploy in Azure Kubernetes Services. So I will get started with that. And let me just give you a walkthrough of the all the details as such. So this is the diagram of the microservice which we will be working with. And okay, let me snip out another picture. Okay, and we will try to take different scenarios. We will understand why something is used and how it is used. All those details I'll show it to you, and we'll talk about it, right? So we'll be seeing this deployment today as part of the demo. We will also be talking about various things like how do you, if you have any cloud native application, what type of data stores do you use for cloud native application? What is the cloud native identity management? How do you do cloud native security? And all the logics behind that. Now, whenever you have any question, feel free to ask your questions in the chat window. I have the chat open in the secondary screen. I will try to take your questions on the way. Otherwise, I will after maybe 20 minutes or 30 minutes, I'll have a look at the chat, I'll just go through the entire chat, and at the end of the session also we will have the Q&A over there. So let's get started. I'll just quickly move this. So the very first thing I want to start from is what is cloud native? Like if you come across this term, or you must have heard this term from your colleagues, or maybe from your clients, or maybe you pitch it to your clients, then you have to explain it to your clients. Then what are the various pointers to talk about over there, or what are the various pointers to know when it comes to cloud native, right? The very first thing is that we will start from the definition of cloud native. So let me quickly open one notepad. Let's see the definition first. Okay, now the definition of cloud native is basically, so we are going through the definition from the Cloud Native Computing Foundation itself, and the official definition of cloud native is something like this. Put it here. Okay. So the cloud native technology empowers the organizations to build, run scalable applications in modern dynamic environments such as public, private, and hybrid clouds using containers, service meshes, microservices, immutable infrastructure, any declarative APIs. These techniques, they create loosely coupled systems which are resilient, manageable, and you can also monitor these systems. Now, combined with the automation mechanism, the engineers can make high impact changes frequently with minimum efforts as such. Now, if I just go to the diagram over here, and if we break the elements of cloud native, like if you have to architect, or if you have to maybe evaluate any application to be cloud native or not, then what are the various thought process, or what are the various pointers which will come to your mind? The very first thing which comes to mind is that, or let me just put some numbers here. So the very first thing, or one of the pillars of cloud native, will be that these cloud native applications, they use cloud infrastructure like platform services from clouds like Microsoft, Azure, very heavily over there. Now, the cloud native applications will be scaling out, scaling in, irrespective or without caring about the underlying hardware. So let's say the application has scaled out, and maybe it has scaled in, and it is totally decoupled, or it is really not concerned about the hardware which is there underneath the platform provided by the cloud. So this is one of the element of cloud native. Cloud infrastructure provides the speed, it provides the agility, it provides the pay-as-you-go pricing, it provides the capability of provisioning fast, deprovisioning when we don't need it, and it provides the operational expenditure versus capital expenditure. So all those things comes into picture. So this is one of the core pillars of cloud native. Like this, cloud infrastructure will be there, any cloud. It might be Azure, AWS, or any other cloud as such. But typically, some sort of cloud will be there. Now, the second thing which is there, now once we know that, okay, we will be deploying these applications in Microsoft Azure, then the second thought comes to mind is that how are we going to design what we are going to deploy? So if you think about the methods by which we do the design of cloud native, there is a method which is called as 12-factor app. So let's just write it down here. 12-factor app. Let's go through it. Okay, so what is this method, right? What are the principles defined in the Cloud Factor 12-factor app? I'll just quickly take you to the website of 12-factor, and you can look up for this website in any of the search browser. You will come across it. Now, just have a look at this, and we'll just zoom in over here. Okay, check this out. So for any application to be cloud native, it should have single code base for each of the microservice, in that single code base, the microservices will be stored in their own repository. Version control will be there, and it should have the capability of doing multiple deployments. Like you can deploy into staging environment, into production environment from that code base. That is one of the factor of cloud native application. Second thing which is there as part of the cloud native will be that the dependencies will be packaged, and we will be creating services which are isolated from each other, and they are packaged with the dependencies. And they, even if you make any change in one of these service, it will not affect the other services which are there. The third feature of cloud native applications will be that the configuration files are you can say managed outside the microservices. You don't hard code anything, and you will be using configuration management tools to manage these services as such, to manage the configuration files as such. The fourth factor of cloud native will be backing services. Now, backing services means any service like cache, maybe data store or message broker. If you know about service bus in Azure or event hub in Azure, or if your application reads data from maybe any third-party location. So these services which are consumed by your microservices to execute normally or to perform normally or to you can say proceed with the business logic execution. Those type of services like databases and so on and so forth are the backing services. So these backing services should be deployed in a manner that they are available or accessible over an URL with the help of some authentication key. And whenever required, you should be able to swap one service and maybe replace it with another one. So that type of capability should be there with cloud native applications. This is the fifth one is, you can say, one of the ones which is very common. This is where the CICD pipeline comes into picture. Now the cloud native application should be having build, release, and run stages, which are isolated or separated. That's a correct term, separated from each other, and these are executed in different stages. And if something goes wrong, there should be a capability of rolling back. Also, whenever you release any artifact, then that artifact should be having some unique ID. And if you make any change in that release, then that will create another release over there. So that's another principle of cloud native. If we think in terms of processes, now these microservices should be, or these services should be self-contained. They should be, they should execute in their own isolated processes. And these states are to be managed outside the microservice using the backing services. Like if you have, if you want to manage the state, you can use Azure Redis Cache or any other cache or any other service to put it over there. Another characteristic of cloud native applications will be that these services will be, the features of these services will be exposed on their own port, and those ports will make sure, and by doing that, we will be isolating one service from another. So isolation will be there by having different port bindings. Now in cloud native, horizontal scaling is preferred over vertical scaling. So your application should be having the capability of scaling out. And once it has scaled out, it should have the capability of concurrently running in the cloud environment, right? And scale in whenever needed, which we will just put over here, that the startup time should be fast, and the graceful shutdown should be there. So when you're scaling out, then the fast startup time will help us in practically running it. Another characteristic of cloud native application will be that, or of your application should be that the environments where you are doing the deployments should be kept similar to each other. Otherwise, it will defeat the purpose of doing testing in one environment if the other environment is not having the same characteristic. They may not have the same scale. Your production environment may be having more machines, and your let's say staging environment is not having that much of instances, but it should be having the same characteristics, or same. The environment should be similar. Otherwise, the test doesn't make sense. Another characteristic of cloud native will be that the logs, all the logs which are collected, will be treated like events, and then you have to make an event aggregator, and that event aggregator will collect all the events and will be storing it in some, or maybe it is passing those events to another log management service like Azure Monitor, and Azure Monitor will maybe store it in the storage account at the backend for long-term archival purpose, and you can create dashboards on top of it like that. Another characteristic, or the 12th characteristic of cloud native, will be that the admin processes which are there will be running independent. They don't, or you can say, they are running in independent, isolated manner, or more, it will be correct to say that they are independent of other processes which are there. So these are the 12 factor app or the methods by which we create the cloud native application. But just by having the general principles or high level principles over here, it doesn't mean that we might be able to practically deploy it. So I will just complement what we have discussed over here with how are you going to do that in Azure. Now, if I just maybe minimize this, maybe cross this page, check this out. Now, those who work with Microsoft Azure may have seen or read these principles before. We have a framework which is called as WellArchitected Framework, and it provides pillars of good architecture. Like if you're an architect and you have to deploy, you have to design a solution for some platform, application platform, data platform, or infrastructure as such, then what are the pillars which, or what are the binding principles, or what are the guiding principles which you should be using, right? What are those principles over there? So if I just drop this picture here and check this out. So the principles will be that the architecture should be reliable, cost optimized, operational excellence should be there, performance efficiency, security should be there as such. Now, what do I mean by that? If we start from the reliability point as such, if you're deploying any application in Azure, then you should be having the application which is designed to handle failure. If there is a local failure, maybe in the rack level, or maybe there is a failure at the availability zone level, or maybe there is a failure at the region level, then how will your application behave in that sense? How will the failover happen, or how will the local copies will take care of it? Where is the load balancing going to happen, and so on and so forth. So you should design applications which are reliable. So they should take care of failure as such. Now the second thing is cost optimization. Prefer pay as you go. Prefer you can say operational expenditure versus capital expenditure. Prefer small deployments. Invest your resources into scaling out scenarios. Do your investment when the scale out happens, and don't deploy. We can say start small and then scale out accordingly, and create applications which can scale very effectively and efficiently. Now, the third thing which comes over there is called as operational excellence. Now, part of operational excellence is automation. Automate as many processes as you can, so you can eliminate the human part of the operations or human part of the deployment, and try to embed the test and the checks using automation. Try to automate as much as possible. Make your operations, or this is part of the operational excellence. Now, the next thing which comes in as part of the well-architected framework will be performance efficiency. Now, as we were just thinking about that, prefer horizontal scaling over vertical scaling. But if you think it through, the problem with vertical scaling is there is always some you can say some upper limit will be there. You may be able to allocate another resource which is having more RAM than the previous one, but there is technically always one upper limit which will hit. And scaling out is more practical. There is no downtime over there. You can scale out, and if you are aware of various services in Azure like scale set, we have serverless scenarios, we have Kubernetes, which very effectively and they scale out in a pretty fast manner. The another principle of well-architected framework will be security. Now, if you have heard about the concept called as shift left, so what we try to do is try to implement or try to enforce security in your software development lifecycle as early as possible. In your CI/CD pipelines, as early as possible, go left in the CI/CD pipeline. So start from the scan your code. Before, when the code is getting checked in the repository, scan the code, scan for vulnerabilities over there. If you are creating any the packages which are being used by the developers. Look for any bugs over there. If you and the artifacts which you have, imagine you created Docker images, then scan those Docker images as such. So try to shift left, implement security as early as possible, where we can fix the bugs with least amount of efforts and with least amount of impact versus finding some major flaw later on in the deployment. So the modern design will be guided by the help of 12-factor application for cloud native, plus the well-architected framework of Azure. There are a few questions in the chat. I'll just have a look at it. So, okay, there is one question: port binding factors. Can you please explain? Do we need to have port binding, or we should have our container app at 8443? Your container apps will not be on 80 or 443. So port binding functionalities are there with all the Azure services, and we should use it. I just want to say that. How will the newly deployed container, which are scaled out, get the traffic from the other part of the system? Now we have load balancing mechanisms. We have service discovery concepts in Kubernetes, and even if we just not talk about Kubernetes, if we just think about that, if you are going to scale out, then what is the entry point? Generally, we have some sort of load balancer on top of it, like traffic manager, maybe front door, or in Azure layer 4 load balancer, layer 7 load balancer. So something will be sitting on the top, which is bifurcating the traffic in the instances which are scaling out at the backend. So that the top service needs to be deployed. Horizontal scaling is simply okay. So horizontal scaling means that if the machine is running out of resources, instead of giving more resources to the same machine, like earlier you had a VM in Azure and that VM was having 16 GB RAM. Now you gave it 32 GB RAM. This is example of scaling up. Now horizontal scaling will be that instead of giving that 16 GB RAM machine 32 GB RAM, I created another machine with 16 GB RAM. And maybe if the rule is still, and they will be scale out, scale in rules. If those rules are hit, then it will further scale out. And accordingly, we should have some rules which are scaling the entire environment in as well. And you will put some min-max limit. So that is horizontal scaling. Okay, now check this out. So the next thing which comes when we talk about cloud native application is that how are we going to logically create these applications, or how are we going to ensure that these applications are, you can say, are communicating with each other. They are isolated from each other. They can have separate scaling environment. They can use heterogeneous data stores. So I'll just draw one picture here. The cloud native applications they adopt microservice approach over here. So let's put one arrow like this. Okay, so what is this microservice, right? What are the benefits of microservice? If I go for microservice approach, I have the capability of using multiple different data stores. If I have requirement of relational databases, I can use that along with semi-structured databases, and I can embed the object storage also, which are there in Azure. Now we will be able to use heterogeneous programming languages. Some languages are good in some particular task. Some languages have some benefits over other languages. So some services might be using some particular implementation of programming framework. Apart from this, all these services will be able to scale independently. We don't have that single monolithic process which is running, and to scale, you have to scale all the different functionalities of the application, which doesn't even require the scaling in the point in time. So to avoid that, the microservice approach will be running, you can say, independent, isolated services. And as per the requirement, we will scale. We will put some rules over there, which will scale some of them when the load comes, right? So we'll think it through. We have further thoughts in it. Imagine the same color services are getting extended. Now, how do you do this? If you practically think it through, okay, so let's say even if we go for microservice approach, what is the next most logical way of deploying it? So the most logical way of deploying it is that you containerize your microservice, and these containers are these boxes over here representing containers. You can use any of the container runtime, and these containers will provide the isolation. These containers will be lightweight. We will also be able to have fast startup time with containers. So when you scale out, the instances will come up very fast. Similarly, you will be able to deprovision them. You can package the dependencies along with the application code, and the containers will make these services independent of the underlying hardware which is there, which will also help you in moving resources maybe from one service in Azure to another, or maybe across clouds also. So containerization makes logical sense. Now, if I do that, right, if I just put it over here, so let's just put some numbers over there. So if we think of elements of cloud native, cloud infrastructure will be there, modern design patterns will be there, microservice, containers will come into picture like this, fourth, like that. Now, if you have these containers, then the next thing which comes to mind is, now if you practically think it through, I'll give you one example. So just to understand the scale of some of the cloud native applications in the which we are aware of. So Netflix has more than 600 services in production. Netflix on any given day, they do 100 deployments per day. Uber is having more than 1,000 services in production, and they deploy thousands of time in the week like that. They do deployments like that. If you're aware of WeChat, right? WeChat is a very popular uh, messaging plus payment gateway type app, or payment app like UPI apps or any PayPal equivalent app. Plus, it's a social media platform, which is very popular in China as such, WeChat. So they have 3,000 services in production, and they do give or take 1,000 deployments every day in those services which are there in production. So the amount of these are the major corporates or major applications which we are aware of, and there will be many more applications including Tinder and other apps which comes to your mind, which are cloud native or which are using microservice architecture. Now, one of the practical problem which happens when you run a lot of instances, a lot of containers, is that you need some sort of container orchestration mechanism. The container orchestration mechanism will provide the capability of doing the networking, of making sure how the traffic will come in, traffic will go out, provide isolation. You will be able to it provides scaling, auto healing, and and the ways in which we can declare the deployment or what you want to do, and then you just post the file, and that thing happens in the cloud. So those type of capabilities comes with any orchestration mechanism. So we have Kubernetes, which is one of the uh, most popular orchestration mechanism, container orchestrator today. And the equivalent of that in Azure is Azure Kubernetes Services, which is the implementation of Kubernetes in Azure with the addition of a few of the container networking interfaces, CNI, and it's a managed service. So you don't have to worry about the head node, and the other nodes will, and the head node comes free, and so on and so forth. So we'll come to that, but we need, with containers, the container orchestrators are also required to run those microservices or the cloud native applications. Now, before we go in that direction, I just want to bring you back to the services which are there. Like, what other backing services which might be there as such. Now, practically, the backing services will be, if I just redefine them for you, or I'll just put one picture first and then I'll just define it for you. So if you have microservices and for them to operate normally, they require, or they will consume some other services like security services, analytical services, caching services, message broker, relational databases, non-relational databases, Kafka-based stream ingestion mechanism like Event Hub, object storage of equivalent solutions, and monitoring solutions as such. So all of these are backing services. All these services are the ones which should be available using an URL and key. And you can also implement these services yourself using any third-party open source technology, which is the only thing you have to keep in mind is that then you have to make sure that the license management is done by you, plus high availability needs to be maintained, and all the services which you see in the screen are platform services like PaaS solutions. So the high availability comes inbuilt, or you can just select the high availability by one click. You can say that I want local copies, I want zone copies, I want global copies, geo copies. I want the backup to happen every 15 minutes. I want tiers of data. I can have SSD. I can have HDD based solutions. So all of these comes with from the cloud, and they are backed by SLA. If something goes wrong, you raise the ticket with the cloud provider, and they will fix it for you. So these are the services which are supporting the microservices, the cloud native applications which you are running. Now, another very important element of cloud native will be automation. So let's put 5. And let's say 6. So these are the 6 pillars of cloud native. Now, when you think about automation, right away, 2 things should come to your mind: that you should be able to automate your infrastructure and automate the deployments as such. Now, when you think about automating the infrastructure as code is the way to go ahead as such. Now, if you have to work with, or if you have to manage your infrastructure from code, there are multiple options which you can go for, and I will just relate with Azure over here. Now you can use ARM templates. ARM templates are there. You can also go for the Bicep templates. Azure is having another template language called as Bicep. It is having less, you can say, the implementation of Bicep templates are more clean, neat, smaller versus the JSON templates, which are having more elements in the template body itself. So you can do the infrastructure as code with Bicep, Azure Bicep. And definitely Terraform can also be used. So let's put Terraform there, right? So infrastructure as code, and this infrastructure will also be maintained in your repository. You can go for Bitbucket, GitHub, Azure Repo, or any other repository which comes to your mind. Now, so this is where we were talking about the automation of the environment or automation of the infrastructure. What happens about the automation of the deployments? So I'll just make one arrow like this over here. So we also would like to automate the deployments, right? This is where CI/CD comes into picture, right? And let's put it here. So here you have CI/CD. Now, if you have joined me for the previous sessions, or if you have joined any other sessions, you must be aware of that. We can do CI/CD deployment in Azure using Azure DevOps portal. And we can also do these deployments with the help of GitHub Action, which we have done in the last session. And as part of the CI/CD pipeline, you are concerned about providing that incremental small value to the end customer. And the thought process behind the CI/CD, which is one of the important component of 12-factor application and also of cloud native application, will be that the cycle between where you get the requirement, you do the planning, you do the build, you do release. That cycle should be small. Incremental changes should be there. The CI pipeline will be, imagine this is a CI pipeline over here, right? Like this. Or let me just pull one picture. I'll just write on the picture. Okay. So this is one example of the CI/CD over here, and you can see that various type of repositories are used. And whenever you do the code commit over here, this is where we would like to do the scan the code, scan the dependencies. Which environment are you using? What are your agents? Where are they hosted? The agents might be GitHub hosted or Azure hosted or might be Microsoft hosted. So either you host your build agents like Linux VMs in your Azure portal, and you provide the connection to Azure DevOps, and then Azure DevOps to execute your CI/CD steps use that Linux VM like that. Or those agents might be hosted by the cloud, and we don't have to host them in our own environment, in our own Azure subscription. So somewhere here, agents will come into picture. And then we will be having the artifacts. So the whatever the artifacts are, those artifacts will be versioned, will be scanned, the continuous delivery pipeline to gain the confidence that whether the whatever artifacts we are creating can be deployed. You will be creating multiple environments. You will have stage environments. You have QA, you have staging, you have production environment. You may or may not be doing the deployments, but let's say you do the deployment, then the pipeline will extend to continuous deployment. And finally, then you might be having some sort of blue-green deployment done, or you might be doing another canary release or ring release as such. So all those logics comes as part of CI/CD pipeline underneath the automation of the deployment for the cloud native application. So if we just summarize, cloud native applications will be having cloud infrastructure, microservice approach. They will be designed using modern thought process and modern architectures, techniques, retry patterns. They will be containerized. They will be having services backing services which can be swapped whenever required. The configuration will be managed outside the microservice using some configuration file which can be stored separately. And when you are moving from one environment to another, you can swap the configuration file. And by swapping the file, you will be able to point the application to another database or another service at the backend. Now, as part of automation, infrastructure as code and automate the deployments over there. Now, I'm just going to read few of the questions. Can you please take CI/CD topic today as well? Okay. We will take it further. Is GitHub Action replacing Azure DevOps in next 2 years? I cannot answer that. GitHub Actions are inspired from Azure DevOps only. We have the same code syntax, we have the same logic over there. And Azure GitHub Actions, they further extend the functionalities of Azure DevOps. Like for example, in Azure DevOps, when you trigger your pipelines, you have limited number of triggers, but that doesn't happen with Azure with GitHub Actions. There you can even do triggers on the amount of triggers on which we can execute any step are nearly endless in GitHub Actions. So we'll see after 2 years what happens. Okay, now we will further jump into the details over here. Now we will be doing the deployment very soon, but now just to start thinking about the cloud native application, or if you think about microservices, there are multiple challenges which you have to face. Now I'll start dropping some architectures, and one of the architecture is what we will be deploying today, right? We will be going through that architecture. Now, if you have various services, then how are the client application communicating with the service, and how the services are communicating with each other is one major challenge. And there are multiple ways in which we can do that. So if you have a very simple microservice where you can see as in the screen, the client application is directly hitting the microservice, then this is one way in which communication can happen. Not really recommended because it's very simple. All the microservices are having public endpoints and the surface area of attack is big. Now versus the client hitting the microservices directly, we can also have an API gateway over there. See, check this out. Now in this architecture, the various consuming applications over here, they are communicating through the API gateway, and then the microservices are behind that. We can do authentication, authorization at the API gateway level. We can do path-based routing. We can do so this is another way in which we are doing the masking, where the microservices are not you can say the microservices are not directly exposed, and from outside world we are doing a type of masking of the environment. So it increases the security and reduces the surface area of attack. We will be protecting the API gateway, or it will be easy to protect the API gateway because of that endpoint. Now, there is using the if we use the API gateway pattern, there is another thing which you should be aware of in cloud native applications, which are using the microservice approach, is that this is also pretty typical. Now, if you just think it through, a lot of time what happens when any company releases the mobile application, the number of features which are there in the mobile application may not be same as what they have in the web application. So the application may have some different features. It may have some more or less feature, and the display limitation will also be different. The web app will be having different display limitation versus the mobile app versus the desktop app. So instead of having the one API gateway where all the different API calls are coming, and then it becomes difficult to implement these functionalities with one API gateway, typically you can also implement multiple API gateways where different API gateways are handling different type of clients. So we have one for web app, one for iOS app over here, one for desktop app, like this. Now, what we are doing is, now check this out. I will relate this with Azure, and that's what we will be deploying. Now, if I just move my whiteboard a little bit, check this out. Now, please remember this. So whenever you have any simple microservice requirement, simple as such, then you can use Azure Application Gateway as an API gateway. And with Azure Application Gateway is a layer 7 load balancer. It does SSL offloading, path-based routing, and it is the one by which we do ingress controller with AKS. Now, this is used whenever we have the deployment for simpler microservice architecture. The other, if you are going for intermediate to large-scale cloud-native systems, then what do? You implement APIM, Azure API Gateway. So over here, right? Application Gateway is a layer 7 load balancer. APIM is it's basically, it's a gateway where we have the capability of creating, we have developer portal there, we have the control mechanism. You can throttle the request coming from various locations. You can do processing on incoming traffic, on outgoing traffic. You can do masking, Azure AD integration. We can do caching in the API gateway. And we have way more, you can say, flexibility and way of versioning. And you can version your APIs. You can do revisions of your API with APIM. It creates many more. It adds a lot of layers of, you can say, functionalities which we can use for scenarios. Now, if I just put that through, now what we will be doing today is we will be creating the ingress controller like that, and we will be using the application gateway
Shivam, you there? Are you able to hear everyone? Yeah, I think we lost Shivam. Just 1 second, I'll get him back. Just give me a minute, folks. There was some technical issue from his side. Hey folks, Shivam is joining back. There was some issue there. So while he joins back, I have posted a workshop link as well. You can keep reading or playing around. There is a sandbox as well if you want to play around. The same workshop which Shivam is driving, it's there in the Learn module with the code, with everything on GitHub. So this is the one. Let's take a 2 minutes break while he joins in. You could also join our LinkedIn group where we keep posting about all these different learnings which we are having, not just the session details, but also the sessions which we are doing, the GitHub repos which we are sharing across. So just give me a minute. The session recording will be made available on the YouTube channel, which we have. So you can also take a look at the channel. Somebody was asking about Docker. There is a session which we did on Docker in 120 minutes. So you can also take a look at that. I've posted a link there. Uh, yeah, this recording will be shared on the YouTube channel. Here is the YouTube channel. So you can subscribe to it or wait for us to upload, and I will definitely share that link in the meetup group as well. So once the recording is available, but recording will be available only by 40. It requires like 48 hours working days. So today is Saturday, so Tuesday or Wednesday it will be up. Shivam, you there? I'm just waiting, folks. There is some issue with his network, I believe. Give 5 minutes. Let me come back.
Hey guys, I'm back. Apologies for that. Let me share my screen. And this is what happens when the applications are not designed for resiliency. So if multiple failures are there, we should be able to overcome those failures. Now I'll just share my screen and let's continue. Right. Okay. So I will just take you to uh, the where I left you with that. Let me see if there is any question in the chat in the meantime. Okay. Now, so we were thinking in terms of how are we going to have the uh, ingress controller deployed, or if we have any deployment where we are looking for intermediate to large scale deployment, then Azure API management is the service which will be used uh, in front of your microservice deployment as part of any orchestrator, container orchestrator mechanism over there. Now, we will be just moving. Let's start with the Kubernetes part of it, right? We'll see what are we doing, how are we deploying it, and how are we going to work with it. Now, what I will do is I'm just going to uh, draw something here. I will those scripts. I will come and I will start deploying it. I don't want to waste your time looking at the script running as such. So let's go through the scripts first. We will understand what are those scripts doing, and then we are going to understand on the way. I will just quickly uh, open one notepad. Or let me do one thing. Let me open uh, the my reference notebook over here and check this out. We will open Azure portal and we will start deploying something. So the Azure portal is over here, and I will just quickly refresh it once to confirm that it is still connected or not. So let's log in again. Okay, great. Now check this out. And we will also, I'll zoom in over here. Okay, check this. The very first thing which we are doing is we will be deploying the container orchestrator Azure Kubernetes services. Now, if you are aware of Kubernetes or not, I'll just start from the very basic itself. I'll cover that and we will do the deployments also on the way. The very first thing is if you want to understand Kubernetes, you have to understand the elements which are there, or you have to understand the various server roles which are there, or how things work as part of Kubernetes. Now, if we can break the deployment in two terms as such. You can say that there is a control plane, and we also have the worker nodes where the containers will be running as part of pods over there. So imagine if I do the deployment at the backend one, uh, head node is coming up over here. So there is a master node here, something like that. And apart from the master node, we will also be having the worker nodes. So let's make two more boxes. Now, what is this worker node? The worker node can be a Linux machine. So this is one of the Linux machine over here in Azure. And we'll just make one more. Okay. Now, how are you going to deploy this? I'll just quickly show it to you, right? Now, I have few scripts ready with me. I will walk you through the scripts, and whenever required, I will find some extra steps, and I will also put it on the way, right? Now, check this out. So basically, we know we have regions in Azure, so we are going for East US, and we are creating one of the resource group in East US. So these are some variables which we are setting, and then we will create the resource group over there. I'll read you through the steps. We will copy the commands, we will run it in the portal, and when it is executing, we will come back to the whiteboard and we will understand what that step is doing. Now, one subnet is coming up, AKS subnet, and there is a VNet called as AKS VNet. So if I just make this box in the diagram, let's move it. Let me see if I can reduce the size of it. Check this. So there is a network somewhere at the backend, like this. This blue line represents the Azure Virtual Network. And inside the Azure Virtual Network, subnets will be there, where the Kubernetes cluster will be there. So you can imagine this blue line to be the subnet and the entire whiteboard to be the VNet over there. And this subnet is part of that VNet. Anything which needs IP address is having the same look and feel in Azure. It's always inside network, and then we have NIC cards, and the IPs are given on the NIC cards. So that thing is happening at the somewhere in the screen. Now, so we are creating one resource group. It's just a grouping of resource. We are creating the VNet over here. So this is the white screen is representing the VNet, and the subnet is also getting up. And we are taking the subnet ID into another variable, and we will just look for the available versions of Kubernetes in the region. And if the whatever available versions are there, we'll create one variable where we will have AKS workshop random, which means like it will get one random name like AKS workshop 1234, or any other random number will get generated. And that is and this is the main command where we are creating the Kubernetes cluster. So what it does is AKS create in the same resource group which we have defined that's the name of the Kubernetes cluster, VM type scale set, node count 2. So it will be how we can see it in the screen that there are 2 VMs over there. And a load balancer will be there, standard. Kubernetes version will be practical versions available. Network plugin will be Azure plugin. Subnet ID from the top. Service side range will be there, DNS service. Some more addresses for the Docker bridge address inside the nodes, and generate SSH key. Okay, so what I'll do, I'll just copy it. So let's just go to the top. Okay, great. Right, and let's go to Azure. Okay, now I will just see if it is executing properly or not, and we will go back to the whiteboard and we will start thinking about it. Okay, great. I am just waiting for one pop-up to come. Okay, sorry. Yeah, I would like to deploy this. Done. This may take some 5 minutes or maybe 10 minutes. Now, if any of the steps take too much of time, I have the backup with me as well. I have done the deployment in another location. It is open in one of the tabs over here, maybe this one. And if it takes too much time, we will run it, but we will go and see it parallelly in another in the previous deployment. So let it run. Let's see how much time does it take, and we'll just go back to the whiteboard. Now, what is coming up is 2 nodes will be there, and another master node will be there, but we will not be managing the master node in AKS. It will be at the backend. We don't even have to pay for it. The high availability of master node is taken care by Microsoft. We have no control in the master node as such. The VMs will be coming up in your Azure subscription. So this is one node. Let's say node 1, and this is node 2 over there. Now this node 1, node 2 are virtual machines in Azure. Something like that. Now, as inside the master node, we will be having 4 different services which are there. We call them server roles. So API server is there. API server. And everything which happens inside Kubernetes will be having some states. So if you have states, you have to store it somewhere. So there is one database at CD. So I'll make one database like that. It is called as etcd, like this. There's a database. It's going to keep all the internal states of Kubernetes. And then we are going to have schedulers are there. Scheduler, for example, if you are deploying something and the imagine one of the node is having more resources versus the other one. It is not exactly uniform, or the resource utilization was not uniform. One of the VM was having more allocation versus the other one. Now, in that scenario, scheduler will be able to understand that where to schedule this pod and where is the how can we make sure that you can say we can distribute the deployments in the nodes over there. We also have controller. There are multiple type of controllers. And what these controllers do, these controllers basically try to make sure that the cluster state is equal to the desired state. What is the desired state? Desired state is, imagine this is where you are sitting. You are the administrator. You're sitting over here, right? Like that. Now you open your laptop, or you have some machine over here. And in this machine, you have installed one client, kubectl. So this is kubectl. And now you are running you can say you are posting few files to the API server, something like this, right? Now, whatever you have defined in these files, we call them as manifest files. Let's say manifest. So if I want to deploy something in Kubernetes, I want to deploy another type of networking. I want to create multi-tier architecture over there, or I want to deploy microservices, or whatever I want to do, I have to declare it, and then I post it, and then that is taken care by the API server. Now, if we just go back to the Azure portal and see if that has executed, great. So the Kubernetes cluster is up. We can go and have a look at it. So I'll just click on the other option over here. Okay, for ingress controller, you require application gateway. Now I will just show you that the resources must have been deployed. So I'm just going to click on the resource group, and let me just slightly zoom out. It's too zoomed in for me. And this is the AKS cluster right now, that one over there. So this got deployed. It is having 2 nodes. It is having few namespaces. Now namespaces will be used for isolation. You can create multiple different namespaces, engineering namespace or project related namespaces. And accordingly, we can have the logical isolation in the between the deployments in the entire cluster. Now, if I just walk you through this, so I can click on this workload, and we have this section called as pod. We will see that in a few minutes, what happens, what is the meaning of pod and all that. And you can see services are here, some storage, other configurations are there in the UI. Now, I'll just go back to the, yeah, is there any question? Okay, I'll just proceed then. Now, check this out. So we'll just go back, and we'll start thinking through it. Now, if you practically have to work with, if you want to practically deploy the any container orchestrator, the most logical thing which comes to mind is that, okay, so what are the things which we require? So developers will be, let's say, are creating the incremental changes, and those incremental changes are getting checked into a repository, and then artifacts are coming out, and those artifacts needs to be deployed finally in the entire CI/CD pipeline. So if I have that artifact, I also require the location to store that artifact. Now, artifact can be like a zip file also, which is stored as in your repository with a release number over there. Artifact can also be images where these images are Docker images or container images where the application is packaged together. All the dependencies are there, and they are ready to be deployed. Now, if I think it through, if I have to store the artifact somewhere, I need a location where I can put that. Now, the location where we would like to do that, I'll just show it to you. Let me just run this get credentials. What it will do, it will authenticate my session, which is in the Cloud Shell with AKS, and we will be able to run some, you can say, commands like get node, get namespace. So get node will give us the information about how many nodes are there. So 2 nodes are there right now. We can also get other information from there. So let's just go back and press enter. Okay, and check this out. Okay, now we are sort of authenticated. So let's see how many nodes are there. And let's wait for it. Great. So they are running pretty happily right now. Now, the next thing is we would like to, so we were just thinking it through, right? That if you have multiple teams who are doing deployments or multiple projects are going on, and you have a big Kubernetes cluster, and you are looking for isolation over there, then how can you get the isolation? So we have this namespace concept. Now, what we are doing is we are creating one namespace which is called as ratings app like this. So this namespace will get created, and let's just go through it in the diagram. So imagine in this node, I have this logical namespace like that. So something like this. So this is what I have just deployed. One namespace which is having the name ratings app. And we can just we'll just call it out. Something like that. That's what we have done. So this is the namespace. Okay. Now, what I would like to do next is, if I have the artifact, I would like the location where the artifact can be stored. So now if you, and the artifact which we are going to talk about right now is the Docker container. And these container images needs to be, the container images needs to be stored somewhere. So how do I store it? So you must have heard about Docker Hub. In Azure, we already have. We have an inbuilt mechanism which is called as Azure Container Registry. That's something which we can also integrate with network. You can bring it inside your network. You can have private connections to it, and you can securely make 2 of your resources in Azure talk to each other without exposing any public endpoint or the traffic going outside your environment. So this is something which help us in creating environments which are more secure, or where we have more control, where you can apply rules of firewall, rules or network security group. So ACR is something which is very practical. It's a container repository, registry, where where the artifacts will be stored as part of your CI pipeline. Today we are not making the CI pipeline, but we will make it manually. We can have the artifacts created manually. So if I just make that ACR, notice this. Now I'll just copy these 2 commands, and I will run that. Okay, check this. Okay, now what that will do is, in my resource group, imagine my whiteboard to be the resource group, right? Now what it will do in my resource group, it is basically going to create, I need more space. I'll just make space here. Now in my resource group, it will create the repository. So this is how we can represent it. Now it's a platform service. So I'll just put it like that. Call as Azure Container Registry. Now this Azure Container Registry is the one where this is the one which can, with the help of which we can fulfill multiple requirements of the multi-factor application which we were going through in the starting of the session. You can create different release environment. You can create different environments. You can have different stages. You can isolate them, roll back. The artifacts which are a part of the, so whenever you want to provide any incremental change, you would like to measure it in a manner like it should. If I'm working on a new feature, I should be able to get the confidence that it's going to work in production. So I'll create the artifact, I will test it out, I will deploy in different environments, and based on the test results, we will be confident that okay, it will work, or maybe it will not work. Then we will fix the bugs over there, we'll open some work items. So this registry is one of the very key component where images are going to be kept. Now, if the command is executed, we'll just go back and verify did that execute or not. So great. Now, if we just go back to the resource group, we should just have to refresh once. That's the ACR. This is the one, ACR 30731. And this is where the artifacts will be pushed. The Docker images will be pushed in the repository section over there. We'll put it here in this one. Now, so when you create these images, how do you what are the things which are required? What is the minimum requirement as such which comes when we create these images? That's the next line of thought. Now, imagine this is where the developer is. That's a developer, right? Now he or she basically is working on this is the application code over here. That's the app code. Now, what we need is that the dependencies which are there in the development environment. So this is the development environment in the cloud, which we are representing by this box over here. And the dependencies are installed there, right? And imagine these are dependencies over here. Now, what we do is we will create one Docker file like this. Now, the Docker file basically means that anything the way in which you want to make the Docker image, that you have to specify in the Docker file with all the dependencies and all the folder structure, directory structure, what particular file should be copied in which particular folder structure. All of that will be part of the Docker file. Now, with the application code and with the Docker file, we can create the image, the container image. Now, technically what happens, you can really make it first and then push it. That also works. But what we would like to do is we would like to say, let me just make the box here. So this is the image. That's the image. Now this image is having the application code. We will just represent it like that. And these are the dependencies to make the application code run like that. Now, what we are going to do is, instead of making the image locally, for which I need to have a lot of prerequisite, what the most logical or the way we do it in production or the way we do it with CICD is that we use the capability which is provided by the ACR, which is called as ACR build. So we can just go to ACR and we can say ACR, that's the application code. This is the Docker file. Why don't you build the image for us? So what ACR will do at the backend, ACR will create the build agent. So this is the build agent and we will be charged for the build agent. So that's OK. So imagine this is the box representing that agent, and then the final image will be there once it is created inside the repository. So the image went over there, all the dependencies are there, and definitely version will be there. So this is version 1 of that particular image. Now, let me see till where I have configured. I will just proceed from that point. So we have just deployed the ACR, and I'll just zoom in over here. So hopefully it will be visible. If not, then just look up in the notepad where we are discussing it. So if I just show that part again to you, so this is the repository which I'm cloning. The link of the files are there on the meetup page. There is a URL over there, and if you click on that URL, you will go and to the same repository, and you can also do whatever I'm doing over here as such. Now we are cloning this. Here we have the application code plus the Docker files are also there. We will just change some directory, and we will start with the ACR build operation, right? We will say ACR, please start doing the build and find the Docker file in the same repository, in the same location. So I'm just going to copy Maybe till here. And it should take some time. So I'll just go through the uh, questions in the meantime. Okay, now there is one question. Hope there won't be any changes required in case of ARO. What changes comes to your mind? Do let me know about that. So is there a free subscription provided for this session to practice? You can just go for Azure free trial. It is part of, just look up in any of your search browser. You will get $200 subscription over there, or go to MS Learn. In MS Learn, a lot of sandboxes are there. You can use them, right? That will be application gateway. I think we already answered that. Okay, in which scenario can we prefer AKS over Azure container instances? So let me run the next build command, and I will answer your question on the way. So one of the application, the image got created for one of them, and we are just doing the second one. So here we have the rating API. I'll tell you what are we doing. And this is the first was the rating API, and this is the rating web app. I will show you what do I mean by that. So let me just quickly run it first. Okay, now Kubernetes is a, I'll give you one analogy, right? And that analogy may or may not make sense. So sometimes it becomes slightly difficult to visualize the container orchestrator solutions. So the analogy is with the old school server platform. So think it through. Imagine you're working in a very big data center, right? And you have thousands and thousands of servers to manage. Then instead of going to each and every server, what you will prefer is you will prefer one central server, which where you can sit and you can run some commands, you can declare, you can run some scripts, maybe templates, and you can just deploy that on those thousands of servers. So, and the other scenario might be there that you don't have that thousands of server in the data center. You are managing one small Hyper-V host, one or two or five Hyper-V hosts. Then you may not require that orchestrator, because that will just add extra steps for you to execute to be able to manage those 5 server hosts. Thinking in the same term, if we what Azure Container Instances, what ACI is ACI isn't uh, ACI is not it doesn't provide the orchestration mechanism which Kubernetes provides. ACI, so for example, Kubernetes will be able to have those 100 nodes and 250 pods per nodes, and scale out. You can have horizontal scaling mechanisms. You can scale the nodes, scale the individual services. ACI will not be having all those functionalities as such. So if you just want to run one or maybe a pair of container, you have a sidecar pattern as such. Or maybe you have just 2 containers, you want to deploy them, main container, supporting container. You are not looking for uh, microservice architecture, or you're not looking for any you are not looking for managing a lot of containers, then ACI will be your way to go. If you have the requirement of Kubernetes, if you are running those multiple instances, microservice architecture with where you need one orchestrator to help you with the networking, with the deployments, the capability to run something on multiple nodes and then fire and forget, it will auto heal it, auto scale it. So then you are looking for Kubernetes. Now okay, this is the image is getting built, and some of the things might have deprecated. So, but I think that's fine. I saw them before as well. Now, what is going on is that we finally will be having 2 images over here. So I'll just put it here. So this is version 1, and this is another image over there, right? Like this. So that operation is going on, and we have to wait for it. I'll just copy my ACR name in the meantime. Okay. I'll just copy my ACR name in the meantime and keep it with me. I would like to use that later on. Okay, so the images are in ACR now. If I refresh and click on the repository, we should see the images over here. See, rating API and rating web. Now, what we are doing is basically we are deploying. I'll show the application to you first. So you see this. The scenario is that there is a ratings website which is deployed on Kubernetes in Azure, and this particular microservice is having uh, three different type of services over there. We will be creating MongoDB backend. So this is MongoDB backend. I will just represent it like that, maybe just like this. And then we have one, we can say front end service over there. So this is the front end service, front end service over here. Now there is the third one is the API. So in the middle, there is one API. So basically the front end is using the API to access MongoDB, right? That's the scenario which we are working with. That's the scenario which we are deploying. Now to do that, I have two images over here, which I will be using. And I will do one thing. I will just move this to my secondary screen. I'll just quickly see if I can zoom out and move this to my secondary screen as well. Okay, there is one question in the chat saying, so the sample will be with service principal or managed identity? Okay, that's a pretty, so first of all, what is service principal? What is managed identity? Right, that's the first thing. So I'll explain that, what is service principal versus managed identity. And we have used service principal in most of the locations. Now, before we can do any image pull and deploy in Kubernetes, we need to connect the ACR with AKS. It is yet not connected. They don't. They are not connected to each other. They are not authorized. There is no authorization between them. So we have to do something like this. I'll just make a dotted line here, right? Something like this. Or I will just put it maybe like this. So we have to attach ACR with AKS. That's the step. Now, how do you do that? Now we will do it with this command. Notice this. So the name of AKS, I will just quickly copy the AKS name. Okay, and I will also pick up pace. We have press time available. So let me just quickly make up for time. Notice this. Now the name of the AKS cluster is that. Resource group name is same. That's the name of my ACR. I'll pick it up. And what I have done over here, I have given the, we are attaching the ACR with the help of the ID of ACR. There is a concept called as resource ID in Azure. Sometimes what happens, the resources are not found by the name, then it is advisable that you find them with resource ID. That can resolve few of the errors. So when I was making the backup of the demo, I found that it was not resolving from, okay, so let me read it that. Okay, so update resource group attach. The resource with the name this and registry could not be found in the subscription. Is it? Okay. 1 second, let me see if I copied the wrong name. Let's just quickly wrap it and read it once. Okay, I'll do one thing. I'll just run two variations of the same command. And the AKS cluster name is 6507. Is also fine. Okay, so let's see if the gods of Azure will find the ACR, which is in the same resource group. Okay, seems like it got found. Okay, if it runs, then what it is doing is this. Basically, it is attaching both of them. Now, once we have done that, right? So once we have done that, I'll just wait for it. Okay. Okay. Anyways, in the meantime, I'll just show the next. We'll discuss it in the whiteboard while it is running. Now, the next thing which we want to do is we have created the images, but we haven't deployed anything yet, right? So what we are deploying is looking something like that. I'll put it here and I will just make it full screen. Or I will just snip the picture and it will not be so pixelated. And I am just going to put it in the whiteboard, something like that. Okay, now notice this. So the next few steps which I'm doing over here are in this diagram, in this particular box over here. There are three things which we will be working with. So think it through. If there is a database and any application or API wants to talk to the database, then we need some sort of authentication. Some username and password will be there, right? Now, it's not recommended that we hard code the username and password inside the microservice. We thought it through that we should be having some configuration file mechanism or maybe key vault mechanism or secret management mechanism where we can put the secret and we can refer to that inside the notebook at runtime. So that is this MongoDB secret. So we will be having some username and password, and we will create one MongoDB secret, and that will be referred in the during the deployment time. Now we are going to deploy one pod. What is a pod? So whenever you run anything inside Kubernetes, basically uh, one logical uh, one logical unit or one logical box or the smallest unit in Kubernetes is called as pod. Like VMs are the you can say smallest functional unit, something which is like atomic in nature in virtualization. So similarly, containers are like the smallest unit. Here we have the pods are the smallest unit. These are logical in nature, and the container will be created from the image inside that particular pod. So think it through. This is where the website will be there, and some dependencies are there, and so on and so forth. So that's what we want to deploy. Now, we will be having one pod where we are deploying MongoDB. So MongoDB over there. On top of the MongoDB, for the MongoDB to be for the name or for that particular service to be resolved, we will be creating a service in Azure, and this service is resolved throughout the cluster. So if anyone reach out to the service, uh, they will be able to reach out to the pod, or I will put it in another manner. To reach out to the pod, you have to talk to its service. So service is like a package forwarding mechanism. And if any package comes to it, it will forward it to the pod, which is behind that. So these three things I have to do. We have to create the service for the backend. We have to create the pod. We have to create the secret scope or the secret management, that secret scope called as Mongo secret. So I will start doing that. And so great. Uh, demo is not a demo if it doesn't breaks live, right? So, and I hope Azure let me connect both of them, because oh, hyphen attach is not there. Okay, let me just check out whether I have just give me 1 second. Let me just quickly check in my secondary screen. I'll copy the original command and we will just modify it one more time. So let's just take it. And ACR name is ACR 30731. 30731. Great. Looks correct. Actually, it will remove the Azure CR.io from there. So I can give it like that, but it should technically remove it and then find it. Okay, now I think this is the reason I was giving it the other way around. And I am pretty sure the resource is there in the same subscription and it's next to each other. Okay, so just go to the backup deployment and we will continue over there. Okay, no issues. Now I'll just show you the backup. I'll just take you to the backup over here, and let me just try to give it without that. Okay, no. Okay, anyways, check this out. So we'll just go to the previous deployment and we'll continue over there. So I'll open the Cloud Shell over here, and I will just wait for it to connect, and I will just duplicate my screen for it to show like that. Okay, and this is the AKS workshop, exactly same, and that's the AKS cluster over there. Now, what are we doing is so we have to practically do these 3 deployments over there, right? We have to create the secret, service needs to be created, pod is not there, we need to create the pod. So once the Azure Container Registry is attached with the Kubernetes cluster, the next step which we are coming to is the deployment of that backend. Now, we are using the application package manager of Kubernetes called as Helm, and we are using Helm to deploy the MongoDB for us. Now, what is the command to do it? How do we do it, right? If I just open the notepad and I'll put the commands over here. I've already executed them. So I will see if I can uninstall and execute for you. But basically something like this, right? Now, what I am looking for is I'm looking for the MongoDB chart, and that MongoDB chart is the one which will pull the image of MongoDB and will deploy, and that's what we will be working with as such, right? Now we have to set the username and password for it as part of the connection string. So you will come to the connection string and the username, and give some practical username over there and password. You can also put these values in Key Vault, and then you can have a logic that it is being pulled from Key Vault first, and we are not hard coding it anywhere. I'll just put one random number over here, so something like that, like this. So once I have the authorization set with username and password, the next thing which needs to be done is to create the secret inside Kubernetes. So the command to do that is like this, like kubectl create secret, Mongo secret. What is this? This is that particular service over there, this particular secret scope over here. And it is part of the rating app namespace. And what is the value of that secret? Like the username and the password. So I'll just complete this command for you. So that's the username, and this is the password over here. I'll just copy it up, and I will just put it there, right? Like that. Okay, so once we run this, this will create that particular secret scope. Now, the next thing which is there is we have to deploy the ratings API. Once the MongoDB has been deployed, the next part is the middle tier. So I will just take the picture out of it and put it here and just zoom in for you. Or I'll just snip out another picture and put it up for you. Okay, great. So the ratings app backend is there. Now the next thing is we would like to have the API which the front service can use to get the data from the MongoDB, right? Like that. So this is what we are doing here. Same concept. We will be creating pods over here. The ratings API is the name of the deployment which we are giving, and we will be creating one service on top of it. So if you can see in the diagram, this pod is talking to the service of MongoDB, and then the package will be forwarded to the particular pod where that is running. And the same logic will happen with the front end also. Like that will also talk to the service of the API, ratings API, and via that it will get the data from MongoDB. Now to do this, we will be writing one YAML file. So this is the manifest file which I was talking about. So I'll just quickly show this to you. We will go to the Azure portal. We'll click on this, and we will say, let's say code ratings -API -deployment.yaml. So I want to make that file. So, and I will show it to you. So please have a look at this. Okay, this is a typical YAML file. So what we are doing is we are creating the ratings API over there. Now the label, so there is a label which is associated with it, which is called as ratings-API, and we are pulling this information from the ACR. The image is in ACR, so what we want is the image should be pulled. We have already pushed it. The name of ACR we will just quickly go and copy. So imagine if this is my ACR, I'll get this name from there. I'll put it here, and that's the FQDN as such. Azure ACR 277.azurecr.io ratings app API version 1. That's the full image name. Now the application is listening to the port number. It is using MongoDB URI will be there. From the secrets, it will get the authorization, the username and the password. The minimum resources are specified over here, like that, and the maximum resources which the container can get are specified here. And then, is the container healthy or not? We can do that check. Now, if we just save this file, I'll just zoom out. And if I just can save this file, okay, great. Now the next thing is we just do kubectl apply, select the namespace and what is your the manifest file name over there, the file name. So the command is as simple as this. So kubectl apply namespace rating app, and the file name is rating-api.deployment.yaml. Once it is done, the pod will get created. So if I show you how that pod looks like, I will just get the credentials of the AKS cluster here, and we can get the information about the pod. Okay, one second. Okay, so and the cluster name is different. I'll copy it. That's the cluster name. Let's put it there. So just need to connect with the cluster, otherwise it will not let me run any commands against it. Okay, great. So now we will just say kubectl get pods, and the pods are running in the name space, which is called as ratings app, like this. So let's do that. Okay, now if you notice, I have one MongoDB backend. This is the one which will get deployed in this step over there. So which is, you can see, are running healthy right now. Now after that, the next step which comes is that we have to create the service on top of it. So how do you create the service? I'll show you the syntax for it. And if I just put it over here, have a look at this. So similarly, I have created another YAML file, and that YAML file is basically is a kind service, and it is having the name ratings-API, and it is using port 80. The target port it is 3000 as such, and it's a cluster IP. So technically, what will happen is this service will be resolved throughout the cluster, and anyone who wants to talk to the API can talk to the service, and the traffic will be forwarded to that. Now, once you have created the YAML file, you have to basically do the same process, kubectl apply namespace, in which namespace you want to deploy that, and the file name. Once it is created, you can get the information of your service in this manner. So I'll just write over here. So I have this, the IP of that particular service is 10.2.0.252. Now I will deploy the show the front end part as well. So the third thing which what I want you to show is something like this. Check this out. Okay, now check this out. Okay, so we have talked about that, this, and the this is the third pod which we are deploying, where the front end is there, and we will be looking for public IP address over there. So I have executed the same logic. I have created one deployment for the ratings web app, ratings web, that's the name of the deployment. And I have pulled the ratings-web version 1 image name from the ACR, which we have pushed before, and we have associated resources to it, and we have associated min and max resources to the to that particular instance. Now once you deploy it, once the service is created, the IP address is available with using a command like that. So I'll just show it to you, and I'll paste it over here. And the public IP address is what I'm concerned about right now. This one, 20.85.129.108. Okay, so if I just copy that, this is the one where oh, I think I have done more configuration there, but I'll just show it to you anyways. So this is the IP address where we have the web app deployed. Now, what happens if I'm looking for path-based routing, where if you are looking for www.contoso.com/images, you go to some particular, you resolve into one service, and if you are looking for images or some other slash, maybe license renewal, license apply for license or new license, so there can be multiple different path which may resolve in different or may resolve to different services at the backend. So what happens if we are looking for that type of requirement? For that, we have to create the ingress controller where we will be able to take care of it. Now, the ingress controller can be deployed using Nginx. You can have Nginx pods, and I will just put it through. So let me just put it here. Check this out. Okay. Now, if you can notice over here, like this part. Now, these are the pods where Nginx is deployed, and that's the service for Nginx. And this is where the Nginx is behaving like the ingress controller, and it is helping in doing the termination of the secure traffic and the path-based routing or layer 7 load balancing over there. Now, there is another mechanism where we can deploy the ingress controller without using Nginx. That's where the application gateway comes into picture. So the architecture is something like this, and it is available in the Microsoft documentation for AKS. If you just look up over there, you will find the steps to deploy it. So this is your app gateway, like that. And this is the Kubernetes cluster. So I'll make 2 nodes over there, like this, in this manner. Now, if you're aware of app gateway basically provides the functionality of SSL termination and provides the functionality of URL based routing, right? And it also have the firewall inside it. There is a web application firewall concept inside app gateway. So now, once we do this configuration, something like this is going to happen. See, think it through like that. So I'll just imagine the traffic is coming like www.contoso.com /images, and I have another traffic which is coming for /videos, and this is where I have deployed the service where, or actually some exceptions happens in this type of deployment. These services are bypassed when app gateway is connected to the is acting like the ingress controller. You can check in the documentation. A few exceptions are there in AKS with application gateway. Otherwise, it works normally like open source Kubernetes. Now, just to put it through, now the traffic was coming something like that, and then the app gateway will be able to send it to different pods over there. So here I have some logic which is running the image logic for my website, and maybe this is where I have few pods which is running the logic for the video as such. So /video/images. Now, to do this configuration, AKS generally creates another pod, one isolated single pod, where the configuration is copied. So there is a particular way in which we deploy it. So, but it does it does what Nginx can do as part of the ingress controller mechanism of Kubernetes. Now, I have already deployed that, and the IP address for the, and I'll just show you how I have done it. I'll open the notebook where I have placed that particular syntax. So please notice this like that. Now, basically the name of the, so we're doing kind ingress, and this is the IP address, which uh, uh, the front-end IP address, and the port is 80. There is no SSL certificate right now. So this is the IP address on which my website is finally running on over here as such. This one. The other one was bypassing it. Now, the last thing which I just want to talk about before I take your questions will be what happens if we are looking for not a MongoDB inside Kubernetes cluster. What happens if we are looking for any of the backing services in Azure? How do you do the migration? How does the Azure services comes into picture? So if you're talking, so we have to bifurcate the requirement into either is it relational or is it non-relational, semi-structured in nature? What type of data is required for that particular step? Now, if you are thinking for relational database scenarios, Azure SQL is available as platform as service and in serverless mechanism. We have MariaDB, we have Postgres database. Azure Cosmos database is one of the database which can do the, which can cover the semi-structured requirement of your company. It can behave like the it can behave like the document store, key value store. We can have columnar Cosmos database and graph database. So if I create one Cosmos database, imagine, so this is where I have that. I'll just put it in the screen. So these are the instances. And if you're aware that Cosmos database is a global distributed database, you can have multiple endpoints. So there is a namespace like this, right? Like this, that's the namespace. And these endpoints are there of Cosmos DB. They are syncing with each other. Now, typically, what do we do? The migration from Mongo database to Cosmos database will be one of the simplest possible scenarios which are there. And Cosmos database provides full compatibility with MongoDB. What we have to do is when we create the Cosmos database, we have to create the Cosmos database with Mongo API. So Mongo API. Now, if I just quickly go to my Azure portal and I just show you that part, is we minimize it over here and go to the Cosmos DB and create like that. The for Mongo, this is the one which is supported. So it will be a document database, but it will be having the support for Mongo. Now create and let's just deploy one. And this is going to be Cosmos DB demo for migration if the name is available. No, let's randomize it. Done. Now the location is West US. I'll just change it. So this is one of the initial endpoint. You can have it in multi-master mechanism as well. Now, do you want it to be like a platform service or a PaaS solution, or do you want it to be serverless? These settings can be done from here. Once you are done, you finally make it, right? Okay. Now, for the part of the migration, there is a service which is called as database migration service. So we will just go to database migration service over here like this and create. And once we create, it gives various scenarios. So if I can zoom in and if you can read over here, use Azure Data Studio to migrate SQL to SQL managed instance and so on and so forth. No, that's not what we are looking for. We want to migrate Azure database. So this is what we are looking for. We want to migrate basically Mongo to Cosmos. So I'll make the second one and I will say select and I will create the project and I will give it some name. So this is DMS service. Okay. Now Yeah, okay, yeah, definitely network needs to be selected. Now, okay, I only have one network, so let's see. Okay, now what this DMS service will do, it in the resource group, in that network, it will create uh, it's a service basically, but it will do some deployment at the backend. So this is DMS service. It is coming up right now like that. Now there are two modes over there. You can do offline migration, you can do online migration. Offline migration means that my on-premise or my Mongo server should be turned off, and then we will sync the documents to CosmosDB, and then we have to go to the application and change the connection strings over there. The second thing is online migration, where the MongoDB is being used in real time, and we are also doing the sync to the cloud. And once the sync has been done, the delta to sync the deltas, we will take a small downtime, and the cutover will be done, and we will fail over to the cloud, and the application will make the application point to the cloud database. Now, this DMS service is like a ready-made service, which once deployed, will will ask for the source and the target, like from where you are putting it where. So you need to have some sort of network connection to your source database. So imagine if my database is represented by this box, so it should be accessible over the network to the DMS service like that, and this becomes the source, and the destination is Cosmos DB. Depending on the size of the data, your migration will take some practical amount of time. Once it goes to Cosmos, you can leverage the functionality of Cosmos DB, and if you're aware of it, you already know that Cosmos database provides multiple type of consistencies: strong bounded staleness, session consistency, eventual consistency. It is one of the solution where you can have OLTP plus OLAP in the same database. You can have real-time analytics and batch analytics done over there. Indexing is there. You can have as many partition as you want. One partition can have 20 GB of data. So all the functionalities are then part of it. Now, I'll just go to the questions, and I'll I'll have a look at it. Yeah. Now there are a couple of questions as such. Where can I find this YAML file? It's already in the meetup page. If you go to the meetup page from where you came, there is a redirection link over there. We'll also put in the chat window. It's there. Now, second thing is, where can is image pull secret not required in the service YAML? I think I showed you that, right? In the YAML, we had that information. It is not required in the service YAML. Where are we using the Helm here? Helm is used to, I'll just walk you through the link again. Check this out. So this is your link, and I will just give you the original link from the meetup page. And I'm just going to copy what Vivek has shared there. Just sharing it in the chat. Oh, I think it's in the chat right now. Now, once you click on that link, which is in the chat, that's where we come. And this is what we have seen. And the Helm was the application package manager, which we have used over here in this part. So what it does, it reduces the complexity. We have these Helm charts. And if you can just look for Helm search repository, you will find the multiple type of charts which are there. If you want to deploy Cassandra or Airflow for any ETL type of configuration, you have that available. Now, this is what we were doing. We were installing the Helm we were installing MongoDB with Helm, and we give the username and password, and so on and so forth. So please check that link in the chat. Go through the tutorial, deploy it. I'll just take few more questions. Do we still need the ingress controller of AKS if we are using API gateway or API M? If you are using application gateway, then application gateway is the one with which you are implementing ingress controller. So you don't need Nginx over there. I will just modify your question. API application gateway will be sufficient to will work in combination with AKS to provide the same functionality. Okay, there is a question. We deployed the MongoDB API and the web app in 3 different pods, right? If correct, then if we have another API, if we have a separate DB of its own, how do we manage the communication between the 2 APIs? Now, okay, basically you're saying that what happens if we, so let me go back to the whiteboard and we will go back to the communication mechanisms. So there can be multiple mechanisms by which your services are talking to each other. The REST calls are one of the mechanism. You must have also came across, we have Google has provided the Google's remote procedure calls, which are like local functions which are invoking other functions in the other pods or other services like that. So there are various methods by which you may have to deploy the communication over there. This is something which we are discussing here. Something like that. If you can describe your question a little bit more, I will be able to help you with some architecture. Okay, I saw your container version number were hard-coded in the YAML. How can it be auto-incremented when using CICD? Okay, in Azure DevOps, we have variable concept. We have, if you have worked with Azure DevOps, we have the options like variables. We have options where you can in templates for just as a thought process. For example, if you're running something with, let's say, if you think in terms of infrastructure as code, you will be able to write your own custom functions as part of your template body with which you can implement any mechanism which you're looking for, like incremental. So if you're deploying multiple resources, you can increment them with some number like 1, 2, 3, 4 like that. So look for custom functions in the template bodies. There is one question that in app service slot deployment, we are getting container didn't respond to HTTP ping on port this. Okay, is that your scenario in production or something? Can be. It might be the problem with your port or SSL certificate as well. Okay, now can I take the DB backup of MongoDB which is deployed in AKS? You can take the DB backup of MongoDB, yeah. Doesn't matter where it is deployed. The agent which is taking the backup should be supporting the should be having the connector to connect to the container and read it normally from there. Yeah. How to match or sync the API gateway architecture with multiple APIM architecture. Okay. Multiple APIM architecture. So this one. Now API gateway itself. Okay, so what this does is And let me see. So you want this to be compared with that, it seems. OK, now we may not have to deploy APIM 3 times. The APIM is a pretty, you can say, it's a pretty complex service which has multiple capabilities. We need to check. So whatever requirement you have, we can practically see it once that whether we need 3 API gateways or not in that, and then maybe with a more subjective requirement, okay, that you are looking for, you have 3 different client applications which you want to read, you want to expose some XYZ services as such. So we can see that why are we not able to implement that with APIM, and then if it is working out, then great. Otherwise, we can think of multiple APIM deployments over there. But if it is required, you can really deploy it. It's just one service of Azure. You will be paying 3 times for it. And I would like to look in the requirement before I can say regarding the multiple API gateway deployment like that. Okay, can you share the ingress YAML with SSL? Yeah, it is there. So please go to the link which is shared in the chat. And if you just click on the enable SSL over there, this is what you're looking for. It's there in the link provided in the chat. Please go have a look at it. So we will create one SSL certificate and we are binding it with the ingress over there. And then it is, you can say, just have a look at this. So this is the one which you're looking for. Same website, same scenario, just follow the unit number 8 over there. Can we use the APIM and app gateway in the same flow over there? Okay, now I'll give you one thought as such. So for example, you have different path. Let's say contoso api.contoso.com. So if the request comes like that, send it to the API gateway. But if the request comes like contoso.com/images, send it to some instances which are hosted maybe in AKS or maybe as a web app or somewhere else. So they can be combined together. They can be. Okay, so what I'll do, I'll put my LinkedIn profile in the chat window. If you have any further questions, even if you think it through and you have a question later on, feel free to ask. And this is what we had for the session for you today. Sorry for the hiccups over there. And I'll see you in the next session then.
Hey Shivam, thank you for the session. If you guys have any questions, can you keep post the questions in the chat? Like we can spend 5 more minutes. While we are spending some time, there is a server link which I have posted with the event ID. Please let us know how was the session and what do you want us to cover in the next session and other things. So even there is an event ID as well. Just key in that event ID and let us know about the session. And also the learn module is been posted in the chat. So there's a question, Shivam.
Yes. What is MSI? I faced issue while creating service principal related to MSI. A managed service identity. MSI is basically managed service identity, if that is what you're referring to. It's of two types: user assigned and system assigned. If you are working with some cluster, it might be the system assigned as such. And the logic behind MSI is that it reduces the complexity of service principal management, and we can manage the lifecycle of the identity by binding it with the service or by managing it as a resource in the resource group, which is user assigned. And the system assigned is the one which is binded to the service. For example, if I have any API, let's say a function app wants to talk to another service. So we'll enable the system assigned MSI, and we will give the rights to the on the MSI to the other service. And then the function app will be able to use that rights to be able to fetch the data or put the output in those locations. Okay, there is a diagram in the chat. Says the certificate management current state of the user, Docker container certificate, unable to inject certificate once the solution is deployed. Target state is Azure App Services. Okay. A TLS termination is moved from Docker container to app service in Azure. Disable the HTTPS for Docker container. Okay, so I will give you one link in the chat, and in which were you able to implement the were you able to bind the SSL certificate, or is that step yet to be done in app services? Just let me know that in that. Let me know about that. Is the certificate binded or not yet? I'll give you the step where we bind the certificate first. I'll give you that. I'll put it in the chat. You have to store the cert. That cert will be stored in Key Vault. I will put that in the chat window. This is what you may have to look for. Go and have a look at that. It's now in the chat. Is it a good idea to deploy DB as a microservice? Yeah, DBs are DB support. DB supports containers, and microservices. They will have their own databases. So you would like to deploy them maybe in affinity or anti-affinity mechanism on the inside the container, and the persisted volume like manage disk or file shares, these can be mounted for the like a persistent volume to the AKS cluster or to the pods as such. Look in that direction.
Cool. Perfect. Thank you, Shivam, for the session. It was really amazing and nice detailed workshop here. And the same thing they can do as well with the Learn module as well. So that's up, and that's have posted as well. Please reach out to Shivam if you have any questions, or reach out to me. And if you need anything, you can definitely reach out to us at the Reactor. And we definitely have a couple of more workshops coming up next week as well. And people who are interested in DevOps, if you want to know how world's largest DevOps company, which is GitHub, how they do DevOps. Do join us for next week, next Friday, where GitHub team is going to talk about entire how they do DevOps and everything. So that will be an interesting session if you are interested in understanding DevOps practice in real, right? So that's something which we can catch up. Cool. Okay. Thank you very much. Have a nice weekend. Take care. Thank you, Shivam. Bye bye.
Thank you, Vivek. Thanks, everyone.